One of the greatest masterpieces of engineering is an aircraft. Currently, there is a diverse range of airplanes designed to serve different purposes, from small recreational aircraft to massive commercial jets. Every type of airplane has its own unique features and capabilities. Now, the airplane engine is one of the most powerful engines on Earth. Modern commercial jet engines can generate over 35,000 horsepower. This immense force generated allows airplanes to reach staggering speeds, with some exceeding 600 miles per hour. To put this number into perspective, most of the powerful cars and trucks use engines that generate about 100 to 500 horsepower. For an airplane to be able to take off, it requires a synchronized interplay of various components. Some of the most fundamental parts of an airplane are the cockpit, fuselage, wings, empennage, engines, and the landing gear. The shape of the parts of an airplane also needs to follow some scientific principles of fluid mechanics and aerodynamics in order to initiate a smooth takeoff. The wings of an airplane is designed in a specific shape known as the airfoil shape. An airfoil is a streamlined shape with a curved upper surface and a flatter lower surface. This characteristic shape is designed to manipulate airflow around the wing, which results in lift. Lift is a force essential for overcoming gravity, and it allows an aircraft to ascend into the sky. In most commercial airliners, the fuel tanks are situated within the wings. This strategic placement not only optimizes the use of available space, but also helps maintain the aircraft balance and stability during flight. The curved upper surface of an airfoil is referred to as the camber. This curvature is essential for creating a pressure difference between the upper and lower surfaces of the wing. The science behind the airfoil's lift generation is closely tied to Bernoulli's principle, which states that as the speed of fluid, such as air, increases, its pressure decreases. Air is a fluid medium, but less denser than its liquid counterparts. The curved upper surface of the airfoil causes the air above it to travel faster, resulting in a lower pressure. When the moving air hits the wing, it encounters centripetal force or acceleration. This is the force experienced by passengers when a car makes a sharp turn. Meanwhile, the flatter lower surface experiences higher pressure due to slower moving air. Now, the faster the airplane travels on the runway, the greater the pressure difference between gravity and lift. Once the lift overcomes gravity, the plane takes off. The Wright brothers invented and flew the first airplane in the year 1903. Incredibly, their airplane also had curved wings, reminiscent of an airfoil. Now, when an airplane takes off, the entire flight process is not complete. The airplane still needs to oppose certain forces to reach its destination. Once the aircraft is in flight, four main fundamental forces act on it: lift, gravity, drag, and thrust. As the plane tries to generate lift, the overall weight of the airplane, or in other words, gravity, tries to pull the plane downward, back to Earth. Furthermore, as the aircraft travels faster in air, it cuts through air with speed. The air tries to resist the airplane and slow it down. This force is known as drag in aerodynamics. To oppose the drag, the aircraft needs a force to push it forward. This force is the thrust, or simply the engine. Jet engines work on the principle of sucking in air, compressing it, mixing it with fuel, igniting the mixture, and expelling it through the exhaust at high speed, creating forward thrust. Jet engines are designed to operate efficiently at high altitudes, where the air is thinner. Commercial jetliners routinely cruise at altitudes above 35,000 feet. Jet engines also allows an aircraft to reach impressive speeds. Supersonic aircraft such as the Concorde, which was retired in the year 2003, would reach speeds of about 1,340 miles per hour, exceeding twice the speed of sound. The Concorde was an undisputed king of air travel. Commercial airplanes routinely operate at speeds well above the capabilities of other modes of transportation, making air travel the fastest means of covering long distances. Now, changing the direction of an airplane in flight is a fundamental aspect of aviation, and it is achieved through a careful orchestration of various parts of the aircraft. Apart from the major components of an airplane, they are also equipped with movable control surfaces that allows the pilot to manipulate their flight path. These primary control surfaces include ailerons, elevators, rudders, flaps and slats. Ailerons control the roll of the aircraft, that is, tilting the aircraft left or right. Elevators control pitch, that is, nose up or nose down movements. Rudders control yaw, side-to-side movements. As an aircraft approaches its destination, the first step towards landing is the initiation of the descent. Pilots begin the process by reducing the aircraft altitude gradually. They adjust the elevators to keep the nose of the airplane downwards. As the aircraft approaches the runway, the pilot initiates a flare, a gentle pitch-up maneuver that reduces the descent rate. This helps to cushion the landing, ensuring a smoother touchdown. A poorly calculated touchdown can lead to severe accidents. On the 27th of March 1977, the Tenerife airport disaster unfolded on the Spanish island of Tenerife. Two Boeing 747 jumbo jets, operated by the KLM and Pan American World Airways, collided on the runway in dense fog. It claimed over 580 innocent lives.